Hello, so we're going to do the review for our probability quiz. So it says at Lincoln High, five students are members of both the chess and math club, so they're in both. There are 24 students in the math club and 13 students in the chess club, and 400 students in the entire school. What's the probability that a random student belongs to the chess or the math club? Into responses of reduced fraction. So we're going to have for this, so we have 400 students altogether, so that's the total. So I think of it everybody for as far as overlap. So we have all the students, 400, and then we have 24. So 24 minus 5 is going to give us 19. So this would be 19. These are the 5 students that are in both. And then 13 minus 5 is going to give us 8. Okay, so this is math, this is chess, this is the whole school. Right. So it says, what's the probability that a random student belonging to a chess club or the math club? Since it's or everybody, that means that we're going to add them together. So we're going to have 400. To chess club. So we're going to have 8 plus 400 over 19. We add them together. And we get 32 over 400. We can divide both of those by 8. So put in the calculator, everybody, or you can also start with even. So 32 divided by 8, you can get 4. 400 divided by 8, we get 50. Oh, still even, everybody, divide by 2 again. So we get 2 over 25. And that's how we get that. Because we do need to add, so I added 24 here because we need to add those 5 students together. So if you think about it like, or you could also do it like this. So 19 over 400 plus the 5 who are in both, plus the 8 who are just in chess club, and we would still get 32. Okay. So either way, everybody, you can think of it either way. Okay, so this one, it's a 20-sided roll die, and outcomes A through D are line below. Which pair are mutually exclusive? Okay, hint, there are 2 correct choices, pick both. Okay, a roll is even for A, everybody is 20-sided. Sided die or number cube. Okay. A roll is, this means greater than 17. A roll is greater than 4. A roll is less than 4. Okay. So roll is even, more than 17. That wouldn't work because we would still have the numbers 18 and 20 in there. And C, roll is even and greater than 4. That wouldn't work because we would have the numbers 6, 8, 10, 12, 14, 16, 18, and 20. So we'd have more numbers that are even. That wouldn't work either. Or it's even and less than 4. That wouldn't work because that would also include 2. Greater than 17 and greater than 4. That wouldn't work because they overlap with 4 and 17. We'd have overlap with numbers 18, 19, and 20. So we'd have overlap. Greater than 17 and less than 4, that would work. Okay, because we would have the numbers 18, 19, and 20 for B. And then for D, we would have the numbers 3, 2, and 1. So that would work. C and D will also work because we would have the numbers for D 1, 1, 2, and 3. And then for C, we'd have all the numbers 4 to 20. I'm just not going to list them all out. Okay, so those would be the two that would work. Both of those will work. Okay, it says a marble is chosen at random, one at a time from a bag containing 6 red, 5 blue, and 3 green. Okay, so we know for the total probability of red if the first marble is red. So getting red and red. Okay, so it's replaced. So we'd have 6. Okay, for this one, everybody, so 6 plus 5 plus 2, so 11. That would give us 13. And then we'd multiply, and then first marble is replaced. So we got 36 over 179. We can divide both of those. Oh, 13. And the events are independent because we did replace them. And that would be our answer for that one. Okay, so 36, you can't simplify it anymore. For the next one, question 4, what's the probability? Okay, Philippe is called twice to take a penalty kick for a soccer match. He usually is successful 74% of the time. What's the probability that he'll make both kicks? So for both, so we're going to multiply, so 74%. Remember, we can divide it by 100 to change it to a decimal. And then we multiply that by 100 if we want to change it back to the percent. It says nearest percent, no decimals, so 52%. What's the probability they'll miss both kicks? So that means it's going to be 1 minus 74% as a decimal. Because that's using the complement, everybody. Zero 0.676. Multiply that by 100, everybody. And then we get number 5 and up rounded up. So everybody, we would round it up. And this, by the way, is 0.0. So that would round up to 7%. And that would be our answer for that one. Robot is rolling a 5-sided dice twice. What's the probability the sum will be 10? Okay, so for 10, everybody remember we can have 5 plus 5. We can have 6 plus 4, 4 plus 6, and that's what we can have for that one. So there's 3. 6 times 6, everybody, because it's 2 dice, would be 36. So probability of rolling sum of 10. We can divide these both by 3. So probability would be 1/12. So 1/12 for that one. Okay, Paul is packing for a weekend in the country. The weather forecast as follows. So on Friday, there's a 15% chance of rain. I'm going to put it up here. Okay, Saturday, 45%, and then Sunday is 25%. So we're going to end up taking what's the probability of no rain. So I changed 15% to a decimal, 45% to a decimal, everybody, and no rain. That means we're going to subtract from 1. And we multiply those all together. So just plug them all in the calculator. Make sure you put in that decimal point, everybody. Okay, and I got 35.06. Multiply that by 100. It says nearest whole percent, everybody. So 5 and up rounded up. If it's a 0, 1, 2, 3, 4, everybody, we leave it the same. So it's going to be 35%. That would be our answer for that one. Okay, this one, everybody. So we have a corkboard. Has an area. It has 2 targets on there, a red piece of paper and a green piece of paper. I'm going to do the red and green. Okay, they do overlap by 90 centimeters. Okay, both of them have a area and then minus 90 because they overlap. So 300 minus 90 is going to give us 210 centimeters squared. Everybody, this is for the targets. Total area is 1,000. What's the probability that the dart will hit either target? So we put 1,000. Okay, so this is for the targets. So both targets. Over 1,110. Cross out the 0. Now we have 21 over 110. So our answer would be 21 over 110 for that probability. So probability of hitting a target. Okay, next one, probability of events A and B both occurring is 12%. Probability of A or B is 60%. Probability of event alone is 55%. What's the probability of event B alone? Round your answer to the nearest whole percent. Okay, so we have 60% for A and B, and then probability of event A is 55% plus, or everybody means that we're going to add them. This would be probability of B. We can also use that. So let's use 12%. That would be both. Is 5%. Probability of event B, 4%. I got 21.8, which would round up to 22. So we got 22%. Match the vocabulary with its definitions, everybody. Dependent is not choosing from a bag and not replacing it and choosing another. Independent, if we roll a die and then choose a card. Mutually exclusive events, having students randomly choose a card. So having a random student choose a card. Permutations, everybody order matters. So an example of that would be first, second, and third place in a race. Combinations, the order doesn't matter. So if we get the top 3 finishers in a race, conditional probability, an example would be a band member is also a girl. So you have 2 different conditions for that one. Okay, we're back to our bands. So, okay, probability that it's black. So there's 13 cards that are black. So 13 out of 22. Probability that it's a van is 3 out of 22. Probability that it's black in a van, so 3 out of 3, which would just be 1. Probability that it's a van and a black, so we put 3 over 22 and 13 over 22. Everybody, 22 divided by 22 is going to be 1. So we got 3 over 13 for that one. This one is dependent. Because the probability that it's a van in black is not equal to the probability that it's a van. 3 over 13 is not equal to 3 over 22. So that's why they are dependent. Okay, a marketing company has shown effectiveness of their campaigns. The table shows a column of 2 results. The search column shows the percent of customers who search for a phone. The search and buy column shows what percent of customers purchase the phone. So we're going to do the probability of search and buy. So for that, everybody, we're going to do, so we take all of them. So 16% divided by 46. Okay, this would be for phone W. We do the same thing for phone X. 14 over 32. Same thing for phone Y. 12 over 35. Same thing for phone Z. 15 over 40. And we calculate all those. We also did these on our notes, everybody. Same with that band question that we just had. Ooh. Okay, so for W, we get that would be 34.8%. For X, we got 43 and 0.8%. For phone Y, we got 34.3%. For Z, we got 37.5%. So that means that the highest would be phone X, and the lowest careful on that one. Notice this is the 3 and that's an 8, would be phone Y. Okay, this one shows the probability for 2 STEM courses by class. So for junior in robotics, percent followed by a decimal. So find the totals, everybody. So that would be 46 juniors. We have 40 who are in robotics out of the 46. 46 divided by 46 is going to give us 1. 24 out of 40. And then we multiply that by 100, everybody. And that will give us 60%. Robotics and a junior. So we're flipping it. Robotics and a junior. Sorry, robotics junior. So now we have 24 over 46. And we get 52%. Remember, you're going to multiply by 100 as well. Sorry, I need to forget that stuff. I need to remember to include that stuff for you. Okay. Game design and a sophomore. So game design, so if we add these together, that's going to give us 40. Sophomores is going to be 16 plus 18, 34. So notice you are needing to get these totals. Okay, so game design. And a sophomore, so 18 over the 34. 40 over that 34 for total. So we cross those out. So 18 divided by 40. Remember to multiply by 100. Oh yeah, we would want to keep that 34, sorry. Okay, so with this one, everybody, game design and a sophomore. No space. Okay, I'm just going to put it up here. Game design and a sophomore. I'm not leaving myself enough space to write. So we're going to put that one. So we're going to put the 18. So there's 18 out of 34. And then remember to multiply by 100. I got 52.9. Everybody remember 5 and up rounded up. So we would round that up to 53%. So 53% for that one, everybody. Okay. Sophomore and game design probability. Okay, so we flip that. So 18 over the total sophomores, which is 40. Or 34. We multiply that by 100, and we get 40%. So total that are in game design, everybody is 40. Total that are sophomores is 18, so then we get 45%. And everybody, we just put in the numbers, so 45. Okay, we continue going, everybody. So survey of students. So we have 50 males, 50 females. 60 said they exercise daily. Of those, 32 are females, so we know 32. So 60 minus 32 is going to give us 28. Total here is 50. So 50 minus 28 is going to give us 22. For female, 50 minus 32 is going to give us 18. So everybody, that's how you're going to fill out this table, everybody. So definitely make sure that you're reading these questions and reading carefully. Okay, for each case below, decide if it's a permutation or combination. Compute the number of arrangements. A student chooses 4 books from a pile of 11. Okay, so number we're going to choose in our R. Okay, so it's going to be, so for this one, everybody, so it's going to be a combination. Arrangement is going to be 4 out of 11 for the combination, everybody. We go to math, scroll over to probability, scroll down to number 3. And then press enter, and then you'll put the numbers in. So I press enter, and then I'm just going to put the numbers in, 4 and 11, and then I press enter. I stand corrected, so it's going to be 11 out of 4, so 4 out of 11, so we do it that way, everybody. So 330. Okay, so it says there are 4 comedians and 5 musicians playing a variety show. Enter responses, reduce fractions. What's the probability the first 3 acts will be comedians? So first 3 will be comedians. So there's 9. And a 4. First 3 acts will be comedians. Okay, so if we have 3 acts, so 4 out of 9. 4 out of 9. 4 out of 9. So we multiply across 4 times 3 times 2, everybody, because once one performs, it's not performing again. Let's try it that way. It might not work. It does work. Okay, so everybody, so the reason I did it like that, so it'll be 4 out of 9. First comedian goes. Now we only have 3 out of 8 performers, and then the second comedian goes, and then we have 2 out of 7. I multiplied across, and I got 24 out of, so I multiplied across 3 times 4 times 2. 4 times 3 times 2 is 24. 9 times 8 times 7 is 104. I can simplify these. You can divide them both by 2, but I actually know I can divide them by 24, and I get 1 over 21. Okay, what's the probability? 2 comedians followed by a musician. Okay, so 4 out of 9. Then we have 3 out of 8. Musician, there's 5 musicians. 5 out of 7. We multiply across. 4 times 3 times 5 is going to get a 60. And we already know that 9 times 8 times 7 is 504. We can definitely divide both of those by 4. So I got 15 over 226. I'm like, oh, I can divide that again by 3. So I'm going to get 5 over 42. So 5 over 42 for that one. Okay, so 2 students are running to become class president and treasurer. Okay, it's going to be a permutation because the order is going to matter. So our arrangement is going to be, remember, we're going to go to math, scroll over to probability, math button, scroll over probability, scroll down to number 2 and press enter, and then you're going to put in the numbers. Okay, so we're going to do probability. It's going to be 6 and 3, which actually means 6 times 5 times 4, which gives us 120. So 120 possibilities. Okay, we got this, everybody.